Alright, good day everyone. Today we're going to be discussing briefly on indices. Indices is a plural of the word index. Alright, so we have index numbers. And the general form of index number in mathematics is in the form a raised to the power n, where a is called the base and n is called the index. And that's where the word indices came from. You can also call it the power. But we say a raised to power n. Can also refer to it as degree. So that's indices. So quickly, let's go into the laws of indices. What are the laws of indices? The laws of indices are the laws that have been co-opted to make calculations in indices be easier and faster. Alright, so no, there shouldn't be I in indices, so let me just get rid of that. It makes the calculation in indices much faster. Alright, the first law we have what we call the multiplication law. Now you need to note all the laws that I'm going to be listing about 5 laws. They are only functional when the bases are equal. So let's write when the bases are the same. Okay, let's use the word the same. That's the only time these laws that I'm going to state out now are going to be functional. Now, first of all, let's just give example of index numbers. Alright, like I've already written, we have maybe let's say a raised to power 2, 2 raised to power 4, 10 raised to power minus 1, and so forth. Alright, so far as there is a base and there is a power, that's an index number. Alright, and further, anytime there is a base and then the power is the unknown, guess what? Now let's pay attention to this index number a raised to power 2. You discover that we know the value of the index as 2, but a, which is the base, does not have a known value. Now that's just, we call it an index number. Now in the case of where we say we have 2 raised to power a, where the base is known while the index is the unknown, this is called an exponent. That a is called an exponent. An exponent refers to when the unknown variable is the index. That's very clear. Multiplication law states that, say we have an index number a raised to power x times a raised to power y. This is eventually going to give us a raised to power x plus y. Now that's multiplication law. Anytime you have a question like this with multiplication law, you can solve it very much faster. So let's do an example there quickly. Let's say we have 2 raised to power 3 times 2 raised to power 5. First of all, I'm going to solve this with the standard form. What you would have done if you don't know the multiplication law, 2 raised to power 3, you're going to expand it as 2 times 2 times 2. Oh my god, so sorry there. That's supposed to be 2 and not 3. It's 2 3 times, that's why it's 2 raised to power 3. 2 times 2 times 2. Then this multiplication times 2 raised to power 5 will give you 2 times 2 times 2 times 2 times 2, and that's 5. That's 5. 1 2 3 4 and 5. So the final answer is going to give you 1 2 3. That's going to give you 2 raised to power 8, because 2 is multiplying itself 8 times, 2 raised to power 8, and that will be answer. Then you can also wish to find the value of 2 raised to power 8 and then put out the answer as your final answer. But using the multiplication law, 2 raised to power 3, we have 2 raised to power 3 times 2 raised to power 5, and that's equal to 2. Because of the bases are the same, there is 2 here and there is 2 here, we pick 1 2 and then we just add the powers. Note, in indices, when you're multiplying using the multiplication law, what you're going to do to the powers is addition. You're not going to multiply. It's 3 plus 5, not 3 times 5, and that's going to give you 3 raised to power 8 very quickly. Instead of using 2 times 2 times 2 times 2 times 2 to eternity, you're just going to do 2 raised to power 3 plus 5, and that's how you have your answer there. So that's multiplication law. Let's make space there so we can go through the next law. The next law is the division law. Now the division law is exactly the opposite of multiplication law. The division law is exactly the opposite of multiplication law. Division law, that's number 2. The division law. Now let's say we have a raised to the power x divided by a raised to the power y. Division law states that's going to be a raised to the power x minus y. Now note, I'm only subtracting the second index number from the first. I'm not doing a raised to the power y minus x. It is x first because x is the first and then y. So x minus y. So example, let's say we have 2 raised to the power 5 divided by 2 raised to the power 3. First of all, let's solve it using the expanded form. This is going to give us this equal to 2 raised to the power 5 is 2 times 2 times 2 times 2 times 2, 5 times, divided, this is the division sign there, 2 raised to the power 3 is 2 times 2 times 2. So 2 is going to cancel this, another one cancels out, another one cancels out. We're left with 2 times 2, which is 2 raised to the power 2, which is 4, and that's the answer. But let's solve that using this law we just learned. This is 2 raised to the power 5 minus 3, and this is equal to 2 raised to the power 2 equal to 4. You see how it became very easy for us. So that's why we are using the laws of indices. Just, it's very easy at this point, but when we begin to solve complex problems, you're going to begin to appreciate the more these laws of indices, and you're going to begin to apply them whenever you're solving mathematics. All these laws are learned so that whenever you're solving any question, you can apply them. The next law we're going to look at is what we call the power law. Please take down all these laws because we're going to be using that. And the power law states that if we have an index number a raised to the power x, now raised to another power y, is going to be equal to you multiply the powers. It's going to be equal to a raised to the power x times y, which is a raised to the power x y. That's the power law. So for example, we have 2 raised to the power 3 raised to the power 5. 2 powers there, so it's going to give you 2 raised to the power 3 times 5, which will give you 2 raised to the power 3 times 5 there is what is 15. 2 raised to the power 15, and that will give you answer. If you want to keep it in ordinary form, then you do 2 times 2 times 2, 15 times, and that's going to give you the value. Number 4, we have the zero index law. Now if you're feeling already, index means the power there, so we have 0 index, it means an index number raised to the power 0 is going to give you 1. Any index number raised to the power 0 must give you 1. Even if we have 1000 raised to the power 0 is equal to 1. 1 raised to the power 0 is equal to 1. A raised to the power 0 is also equal to 1. And then let me add another one here. We have what we call the zero. Oh, sorry, I've written that already. I've written the zero index law. So I'm gonna go with the fractional index law. Fractional index law. Now, from the name already, you know that in this case the index is going to be a fraction. Let's say we have a raised to the power x divided by y. The law states that this is going to be equal to the root of y, the root of the y root of a raised to the power x, please. The y root of a raised to the power x. Okay, the denominator is going to be the root, while the numerator is going to be the power. Why a is the case study. That's very simple. So let me make a space there so we can solve a question on that one quickly. That's the fractional index law. That's the fractional index law. And I want to state again that all these laws that we are dealing on, they only apply when the bases are the same. If the bases are not the same, these laws are not going to hold. Apart from this one, that there is no it is not indices, it's just an index number, so there's nothing like the basis being equal, just one base there. So let's use example on that. Let's say we have 16 raised to power 3 divided by 2. Let's say we have that. Okay, now you see this is 16 the base, and the power there is an index. So 2 is the denominator, so it's going to be square root, all right, of 16, then raised to the power 3. And we know the square root of 16 is 4. The square root of 16 is 4. That's 4 raised to the power 3. and that will give you your answer. Then you can multiply that out and get your answer in the normal form. So that's how to use the fractional index law. So let me make another space there. I want us to solve just one question, one complex question. Not really complex. Indices is a very simple topic. Okay, I think we can go with the laws that we have already. So let's just make space there and solve a question. Okay, the next law we're going to look at, I think that the last law we're going to look at for today is what we call the negative index law. The negative index law. When we have a raised to the power, let's say, minus x, negative x, all right, when the index has a negative value, it's going to be equal to 1 over a raised to the power the positive value of that index. So this is a raised to the power negative x, but when you put the inverse sign, which is 1 over, then you have a raised to the power positive x. So let's solve an example there quickly. Let's say we have okay, we're going to solve it this way. Let's say we have 2 raised to the power 2 divided by 2 raised to the power 3. Using the expanded form, this is 2 times 2 divided by 2 times 2 times 2. So these 2 times 2 cancel 2 times 2. We are left with okay, permit me to do something. I just want it to be more critical. Let's say this is 2 raised to the power 4. So there's another 2 there. So 2 has cancelled 2. Then we're left with 1 over 2 times 2 is 2 raised to the power 2. Is that correct? Yes. So that's the answer, or we can try to leave it as 1 over 2 raised to the power 2 is 2 times 2, which is 4. So now let's solve it using the negative index law. Using the negative index law, we have 2 raised to the power 2 divided by 2 raised to the power 4. Now, first of all, I'm going to use the division law like we have learned. Using the division law, this is going to give you 2 raised to the power 2 minus 4. Now, using the laws of indices to solve, 2 minus 4 is minus 2, so this is 2 raised to the power minus 2. Now, it's not good to leave our answer in this form. So, using the negative index law, when the index is negative, it's going to be equal to 1 over 2 then raised to the power positive. Then you throw the negative away because of your put 1 there. You import 1, you export the negative, and you can go vice versa whenever you want. You import 1, you do away with the negative, you import the negative, you do away with the 1, depending on how you want to do it. So all these laws I taught you so far are interchangeably used. You're going to be using them based on the one that is most favorably disposed to you and the equation that you are solving. So it's not a fixed kind of thing. You can always go one to the other and the other to the other one. So in this case, we want to go from this now to this. So that's how we have there, and we have 1 over 4. So that's it for the laws of indices. In the next video, we're going to solve problems on the indices where the bases are not the same, and we're also going to go into exponential equations. Like I stated that earlier, that whenever the index is an unknown variable, it's called an exponent, and if it's in an equation, is an exponential equation. Thank you for joining in today. Please do well to subscribe to this YouTube channel and follow us for more of this kind of contents. God bless you in no small way.